So hi everyone. Now we are going to discuss stack pointer and base pointer. So when we discuss stack segment, there we discuss about these two pointers. These two pointers are actually holds the offset to address the stack segment. So particularly base pointer will be used in based addressing modes. In that cases we will use this BP, and stack pointer also used to access the data in the stack segment, and SP is used as an offset for from the current SS during the execution of instruction that involve the stack segment in the external memory. So stack segment related executions, that time to access the particular memory location, this stack pointer will give this offset address. So by using this offset address only we will be able to generate 20-bit physical address. Then we can locate the particular memory location. We can track that particular memory location where the particular data is stored, or any stack data is stored, stack instruction is stored, or instruction is stored. That only we can track that memory location by using the physical address, 20-bit physical address. So for that, this SP and BP are used as an offset, and SP contents are automatically updated, incremented, decremented during the push and pop operation. Push and pop instructions, when we are executing this push and pop instructions, that time this SP automatically get incremented or decremented. So if you are pop operations, it will get incremented, and push operations it will get decremented. Then when we are going to discuss about the instruction set, that time we will discuss about this push and pop even briefly. There you will come to know how that SP get incremented and decremented. Then BP contains the offset address in the current SS, which is used by the instructions utilizing the, as I told you, based addressing modes. Next one, source index and destination index registers. So these two registers are used in indexed addressing modes. In that cases we will use, and again these two registers holds the offset. So instructions that process, and also in string operations we will use this SI and DI together to process the data strings. Instruction that process the data string, that time there it will use this SI and DI registers together with DS and ES respectively, in order to distinguish the source and destination addresses. So next, so far which are all we discussed, just overview we'll see in this tabular column. So general purpose registers we discussed in the previous videos. There are four general purpose registers: AX, BX, CX, DX. AX means accumulator register, BX means base register, CX means counter register, DX means data register. So these are the four registers we discussed, and these four registers can be represented with two 8-bit registers also. So AX can be represented with two 8-bit registers, or AL and AH. BX we can represent as BL/BH. CX can be written as CL/CH. DX also can be written as the combination of DL and DH. So these registers we will use for 8-bit operations, and these registers we will use for 16-bit operations. Next one is pointer register. There are two pointer registers we have, SP and BP. SP means stack pointer, BP means base pointer. So these pointer registers are used for addressing the stack segment, and both are 16-bit long. Next one is index registers. So we have two index registers, one is source index and destination index. This source index and destination index gives the offset for data segment and extra segment, and these are used in string operations also. String instructions, we will use this SI and DI to differentiate the source address and destination address, and these two index registers are of 16-bit long. Next one is instruction pointer. So IP means instruction pointer. This instruction pointer also gives the offset for addressing code segment. Okay, and this instruction pointer will point the next instruction while the execution is happening in the code segment. That time this IP pointing the next instruction which is going to be executed. Okay, and this IP is also of 16-bit long. Next one is segment registers. So totally we have 4 segment registers: CS, DS, SS and ES. So CS means code segment, DS means data segment, SS means stack segment, ES means extra segment. So all these 4 segment registers gives segment address. Along with this, remaining registers we will use for offset to generate 20-bit physical address to track the memory location in the external memory. Right? I hope what I am telling, I hope you understood. So far in the previous videos, these things and all we discussed. How to generate 20-bit physical address, what is external memory, what is segment address and offset address. By using the segment and offset address, how we can generate 20-bit physical address, everything we discussed. So if you have a doubt, please watch the previous videos. And all these 4 segment registers are of 16-bit long. Last and final is flag registers. Flag registers means program status word. PSW means program status word. And in that flag registers, what and all we have? Carry flag, auxiliary flag, then signed flag, zero flag, parity flag. These flags are status flags. Next one, trap flag, interrupt flag, and next one is direction flag. Last one is overflow flag. And trap, interrupt, direction, these 3 flags are control flags. So totally these many flags we have, and this flag register is also of 16-bit long. So I hope you understand all these registers and the purpose of these registers. Next one, so general purpose registers and the pointers. So already I told all these things. So just I include this one, just overview of all these registers whichever we have discussed, and pointers, index registers, everything. So thank you. We'll see remaining topics in the upcoming classes. Thank you all.